Right, so in this project, we're going to use Selenium driverless, and I'm going to show you how to asynchronously use it as a browser to scrape some data from a website. We're going to load up this page here. We're going to pull all of the available obvious links, and then we're going to visit each link and pull the information out. Now, this website doesn't necessarily need this technique, but I wanted to demonstrate it to you. So we're going to be using Selenium driverless, which I talked about in my last video. The documentation is here in the GitHub, and this is a great library for using for when you need to use a browser to scrape. We're also going to be using the async.io rate limiter, which is going to let us control how much we are able to, how many windows we're going to be able to open. And I'll show you with and without this, and you'll get the idea of why we want to use something like this.
I'm using a browser for this project, and that makes it even more important to use high quality proxies and to consider the geolocation, as even a non-detect browser like I'm using here, there's always still ways for Antibot to find you and block you. So this video is sponsored by Proxy Scrape, friends of the channel and the proxies that I use myself. We get access to high quality, secure, fast and ethically sourced proxies that cover residential, data center and mobile with rotating and sticky session options. There's 10 million plus proxies in the pool to use, all with unlimited concurrent sessions from countries all over the globe. I use a variety of proxies depending on the situation, but I'd recommend you start out with residential ones, but make sure you select countries that are appropriate to the site you're trying to scrape and match your own country where possible. Also, consider using sticky sessions and keeping the same proxy for 3 to 5 minutes, which is what I'm going to do here. Either way, it's still only one line of code to add to your project, and then you may let Proxy Scrape handle the rest from there. And also, any traffic you purchase is yours to use whenever you need, as it doesn't ever expire. So if this all sounds good to you, go ahead and check out Proxy Scrape at the link in the description below. Now, on with the project.
So the first thing I'm going to do is I'm just going to create my virtual environment in Python in my project folder. I'm going to activate it. ACT is a shortcut for me, otherwise do it in a normal way. And we're going to pip install what we need. So I think it's called Selenium driverless. It is. And then I forget what this is. Async.io limiter. Okay, so let's copy that. We want you. I'm also going to install Rich as well, because we're going to print some stuff out to the terminal, makes our lives a lot easier. So I'm going to create a main file, main.py. I'm going to open this in my text editor and we're going to get started. So we're going to import what we need first. So let's do from Selenium driverless, we're going to import in the WebDriver. I know that's slightly confusing why it's called WebDriver, driverless, but that's just the way that it is. And then because we're going to want to find elements on the page, we want to import in types.by and then import in by. So we can say find this element by the CSS selector or by the XPath. So we need that. We're of course going to need async.io from Python, because we're going to be running this asynchronously. You'll see how many browser windows get spawned when I get to the end and why we need that rate limiter. We're going to import OS because we are going to be using our Proxy Scrape proxies for this, and I have mine stored in an environment variable on my system. I suggest you do the same. I've covered this in another video, but however you want to use them, you're going to need them. And then, of course, from the async.io rate limiter, we're going to import in the limiter class. Right, so we can get started now. So I'm going to leave the rate limiter out for the moment. We'll do it without, and then I'll show you why we need to put it in. But I'm going to do a little thing here. I'm going to say that my proxy is going to be equal to os.getEnv. I'm just setting this up before we even look at the site, just so that I know that it's done. And I'm going to use the sticky proxy. I want to use this one. And then we're going to do if proxy is none, i.e. if it just finds none from my virtual environment, I'm going to go print no proxy found, and we're going to quit out of the program. This isn't essential for you if you're putting the proxy directly in, because I'm pulling it from my OS, my environment variable. If this doesn't find this environment variable, it returns none. So I'm going to make sure that we do find it, just in case I type this wrong and I start scraping on my home IP, which I don't really want to do. Okay, so let's get into the main part of the project now. So I'm going to come back to the website and we're going to have a look at this, and we're going to first open up the inspect element tool, the dev tools here, because we want to find the link for all of these products here. So I'm just going to hover over one of them, and I'll make this full screen now, and I'm going to go back up and I liked this div class here, div grid product figure, blah 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 blah. You can see when I hover over this, it's got everything in it, and from there we can find the link underneath, and that's what we're going to need to do, because we're going to need to collect all the links on the page and then visit them all asynchronously, because we want to get the product information from the product page. So we'll keep that there, and I'm going to open up one of the product pages. And generally speaking, this would be open for you. You can get the data from here however you want. Generally speaking, when I'm doing e-commerce sites or anything really, I always come here and I search for schema. And if I scroll down, we have this here. I'll make this a little bit bigger so you can see it. We have this whole this script type, application LD plus JSON, which has all of this information in it. If I just copy this out and go to JSON parser, my favorite one, online.fr, paste this in, you can see that this is JSON data for all of the products, including this one has the colorways, I think. Or no, it has the sizes, sorry. You can see different sizes here. I think that's the different sizes, yeah. So it has all of the product information. So this is really handy, really good way to get that data out. So we're going to basically just pull that from that element, which is over in here. If I go back to the source. So if we copy this element here, this LD JSON, there's only one, which makes our lives really easy. So we can just find this, pull the text, and it will automatically get put nice and neatly into a Python dictionary for us. So now we know that how we're going to pull the product information. We're going to start writing out our code. Let's start with our main function. So this is all going to be asynchronous. So async def main, like so. And then we want to have, if I just pass, and then we have async io.run, the main function, like so. Cool. So inside this main function, we need to have our async with function that's going async with block, which is going to open the browser, do what we need to do with it, and then close it when we're done. Using a context manager with, when you're dealing with stuff like this, is just generally better idea, because it clears everything up for you at the end. And we'll see that Selenium driverless actually creates a new profile for us when it loads up our browser. We'll talk about that when the browser pops up. But what I am going to do is I'm going to do options is equal to WebDriver.Chrome options. We aren't going to create any options here, but I'm going to put that in just because it's good to know that, and you can add in options if you need to, like anything like this, arguments, exactly, etc., for when you want to launch Chrome. It's very useful in some cases. But now we're going to do async with. I'm going to remove this pass. It's going to get a bit confusing. Async with, and we want to do our WebDriver.Chrome, where the options, I'm going to put this in anyway, options is equal to options. Obviously these aren't really going to do anything for us at the moment. And we're going to call this driver, and then we're going to say we're going to await driver.set single proxy. So because we're using our proxy, we can set this as a proxy, and this means every request that goes through this driver, or every time a browser page is opened, it uses our proxy. So obviously, if we open one browser window and then just keep working with it, it's going to use the same proxy over and over again. And if we open a new context browser window, it's going to use no proxy, etc., etc. So this is what we want to do here. So now we're going to do await driver.get, and this is the URL that we want to grab. So let's go back to this page. This is what we want to do. And I'm going to put in here, wait load is equal to true. Then what I'll do is I'll put in, I think it's async io.sleep. Let's try this. Can't remember if this works. Not 20, do 10, and we'll do wait. Cool. So let's try running this now, PyMain. So we should see the browser open up, and we're going to connect to this page, and it's going to load up the page. There we go, done. So the good thing with one of the good things with Selenium driverless, and I covered this in my last video, is the fact that it uses your actual Chrome install rather than having a separate one, rather than having that actual driver which controls everything, that gives away that automated browser flag. And it does all of the basic cover-up stuff that you need, all of the basic stealth stuff, and it makes it much easier. It does everything through the CDP, which is the Chrome protocol Dev Tools Protocol. There we go, that's what it's called. And basically, it's just a much more modern way of doing it. The actual Selenium itself and Playwright are just fully focused really on testing, so they don't care about all of this stuff, whereas people have then adapted it to give you these sorts of things which work very, very well and are much better. So that's why we're using Selenium driverless. Okay, so I'm going to remove the sleep, and now we can move on. So what we want to do here is want to find all the elements. So I'm going to say our products is going to be equal to await and driver dot find elements, and from in here we want to do by dot CSS, and we want to give it the CSS selector, which I think I've still got open here. Yep, and it's this one, which is, let's copy that, div dot whatever that is. So this is going to give us all of those elements that match that on the page. This could be anything, for whatever you're scraping. Find what the element's called, do a little bit of testing, figure it out, print them all out, see what you're getting. Maybe you need to load another page, maybe you need to scroll. All of that stuff can be done. I'm just going to keep it a bit more simple. On this one, we're going to grab all of the product links that it can find right away for this just concept, proof of concept. So now I'm going to create a list of URLs, and then we're going to loop through the products one. So we do for p in products. Let's make this in the middle of the screen, and we want to do data is equal to await, because we're of course in async here, and we'll do p.find element. So what we're doing is we're saying for each element that you find here, I'm going to look for something else, and that is of course by.css, and we want to find the a tag here. Now we possibly could, that needs to be a capital B. We could probably make this CSS selector a bit better, but you know, I've done it this way, so we'll be fine. So then we're going to do link is equal to await data dot get DOM attribute, and we want the href here, and then urls dot append link. So why am I doing it this way? Why am I not clicking on the links and going through? Well, because I want to do this as quickly as possible, I want to do this asynchronously. I'm going to create a new browser context for every link. I'm going to open them all up together, and I'm then going to be able to visit all of those pages simultaneously, as opposed to having to do it one by one, waiting to go through. And that's where the limiter is going to come in. I will show you that though. So I'm going to go ahead now and just print, we'll do print await URLs. I think that might work. Let's load it up. So we should load up the full page, and oh yeah, I've given it a list inside the, you can't do that. My bad. Okay, now we'll run that, and that will have to be blocking, but that's fine because this is just for demonstration. We're going to create tasks for all of these links in just a minute. So let's just make sure these are actually product links. They are, we can see them there. Great. Let's clear that up and come back to our code here. Right, so now that we've got all of these URLs, we're going to use a coroutine and a task to actually go through them all. But to do that, to create a task, we need to have another function. So what we do with the task is we say, do async coroutine for this task with this piece of data. So I'm going to say do this task, which is going to load the page and pull the data that I want for every one of these URLs. It will create all the tasks for us, and it will run them all asynchronously. So I'm going to call this one async def, and I'm going to call this get data. And in here, we're going to pass in the driver and also the URL. And this is where we're going to create our new context. So a new context is essentially, in this instance, a new browser window, because we want to, scrape as many pages as we need, as many pages as we can. We're going to need that context to load them up. Now, I think when you create a new context, you do kind of create a new version, so you kind of don't have all of the sort of the browser cookies and everything that we were loaded up previously. I think you can pass them through each context if you want to. I'm going to do it this way because I know that it works like this. That's just something to bear in mind. So we want to do await driver.new context, and then we do await new context.get and the URL that we pass in. Now from here we want to say that our schema is going to be equal to our new context.find. I should really have put type hints in this so I had the completion, find element, and by capital B by.css, and now we need to put the CSS in for that element that was in the view source, which I've lost. Here it is, this one. So script type, that's pretty standard CSS selector. Script type is equal to, not that one. Let's grab the rail one, please. Copy and paste skills. There we go. You do need to have the single quote marks here because of the characters, otherwise it won't know what you're on about. And let's remove that. Cool. And then I'm just going to print, and we need to do a wait here, schema.text. If you're ever unsure with async, just stick a wait in front of it and see what happens. And then we'll do a wait new context dot close, because we want to close that context, that browser window, when it's opened and done with. We want to close it so we can move on with our lives essentially and not have a shitload of browser windows open causing us issues. Cool. So now we need to move on to our tasks. So as I said, we needed that function that I just wrote, the get data function, and we need to do that for every URL. So I'm going to call this tasks. It's going to be equal to, I'm going to do list comprehension here, but basically you just need to end up with a list of tasks. So we'll do get data, and we need to give it the driver for URL in URLs. And I need to give it the URL as well, obviously, URL, like so. And then we can do await, and we use async.io, and we want to do .gather, so we can gather all these tasks up, and we give it the list, like so. This is going to give us, hey, all of these URLs need to be run with this function, and we pass it off to async.io.gather to run them all within the async loop. So it's going to work for us. Now, I didn't show you how many links there were, but you'll see in just a second. Okay, so this is why we're going to need the limiter. So let's run this. If I've done everything right, we're about to spawn a million Chrome windows, and it's probably going to crash. Well, it will crash, I assume. So for every link that it's found, it's opening a Chrome window. So how many is that? I don't know. How many? I don't know. Is it going to work? Is it going to crash? It's probably going to crash. Or it's going to time out because it's not going to be able to load these all up quick enough. So we'll get a timeout. But theoretically, this would work. But this is just not the best way to do this. I mean, it's going to time out in just a minute. I think it's a 30-second timeout. One of the pages won't load and we'll get an error. But you can just kind of see that they are starting to load up. If I tried to make one full screen, it's kind of loading up. It's sort of working, but this is just, there we go. Timeout. So that's not going to work. Fun though. So this is where the limiter comes in. So I'm going to create a limiter up here. I'm going to call this rate limiter, and this is a really easy way to limit anything that you put into your async loop here. I'm going to create a limiter, and you get an option. So I'm going to do 1 every 5 seconds to start with, and we'll see how we get on. So inside this function, which is the one that we want to limit, I'm going to do await rate limiter dot wait. So this is going to then now control how many of these can spawn within this within our async.io.gather. It's going to control how many can spawn. Oh, sorry, jumping around way too much there. How many can spawn within this time frame. So I'm going to save this now, and we're going to run it. So we'll do main.py, and now we're going to see that they're going to load up much slower, 1 every 5 seconds. So we might find that this is too slow. So we're going to load up 1, and is this one going to be finished within 5 seconds? And we get the data back. Oh, I never awaited the, my bad. This should have been awaited. Await. Okay, that's why that failed. So just run it again, and we should be fine this time. So let me move this over so we get more windows over here. We're not really too worried about the data coming back. Okay, so it's been a bit slower, so this might time out. Oh, there it did work. So I'm doing 1 every 5 seconds, so it's going to, these ones should start closing by the time we open up new ones. And we can see that our data is coming out over here. So if I made this one full screen, for example, this is the information that we're after. And I didn't put rich in there because I should have done, because it would have been nice and easy, and you'll be able to see it much easier. But now we can kind of see, you know, that it's spawning one up every 5 seconds. and we're kind of doing it a bit quicker, a bit more asyncs. And you can tweak this. I'm going to close this, and we'll come back to our code. And I'm going to tweak this, and you can make this quicker or slower depending on your network connection, what you need to do. I'm also going to do import. We'll do from rich import print, make our lives a little easier, and we'll make this smaller. So now we should have one window every 3 seconds, and we should be able to see the data much neater coming through on the left hand side, and you can kind of see how it all comes together. So this is possibly one of the better ways that to run Scrape with a browser and make it not so impossibly slow. But it does come with a lot more complications because you need to have a good handle on Python's asynchronous runtime, its async loop, how to utilize that to your best usage, and what you can then do with it going forwards and how it's all going to work. So this one's taking a little bit longer to load up the pages, so maybe one every 3 seconds is too many, but it should start ticking away now. Yeah, so we're starting to time out. So one every 3 seconds isn't very good, or you could extend the timeout, set timeout in your code. You can have the timeout extended up here somewhere. But hopefully you kind of understand like the concept here, to get all the links using our Selenium driverless, which is going to give us a really good chance to beat blocking on sites, as well as using the proxies from Proxy Scrape, which is going to help with us too, because we can utilize good strong IP quality there, and we can get through. And then we're just basically using a task to go ahead and grab all of the data. I'm not doing anything with the data, but from here, we've got it in a variable. You could easily do whatever it is that you needed to do here. There's async capable libraries for all sorts of databases, as well as saving to files, so you could easily fit that in within the loop too. So yeah, that's going to cover it for this one. Hopefully you kind of got something out of this. Let me know down below what you think. Go ahead, leave me a like and a comment, and also subscribe as well. That really helps me. But if you want to know how I scrape without using a browser, and how I probably would scrape this site without this and quicker, you want to watch this video next.